So, welcome. Thank you for being here. My name is Thiago Martins. I'm a product manager for the topic digital twins with standards at SAP. And today, I'm not really talking on behalf of SAP, but actually rather on behalf of the Industrial Digital Twin Association, or in short, IDTA, and on behalf of the whole community on the standard called Asset Shell. And the title of today is called Unleashing the Power of Digital Twins with Open Source. And my colleagues and myself brought here a few slides to present you or give you an overview of what's going on the standardization and how open source is helping us or helping the industry to adopt and drive technology in context of several current challenges that we have today. So again, IDTA, or the Industrial Digital Twin Association, is an association from, by the way, currently more than 100 members, 100 companies, and as academia, with the goal to drive the standards for the digital twin or industrial digital twin. And well, today my focus will be rather on the open source part of it. But before I go and give you an overview on the different projects that we are driving, I would like to briefly explain you what is the asset administration shell and why we need it, or where the asset administration shell is helping us. And based on that, provide you a few use cases that are pretty relevant to use standards. And we saw today already a few sessions like Web of Things that there is a huge need on that. And based on that, we would like to present you the open source projects driving this standard, and later on give you a demo showing how open source is being used already to demonstrate the technology based on the carbon footprint example, which is one of the requirements that we'll see for the digital product passport. So let's start with the first question, which is what is the asset administration shell? Briefly speaking, the asset administration shell is the implementation of the digital twin for Industry 4.0. Right, so this is a standard enabling you to build modern digital twins in a more interoperable manner. But if you see on the details, the standard is a little bit more than that. I won't give you the whole details because this is rather an overview, but I'll be happy to provide you more information later on, and also invite you, motivate you to go into the specific resources to get more information. But briefly speaking, the asset shell will give you an overview or a representation of your assets through the entire life cycle of your product. It helps you to provide a unique identification, making the bidirectional association of physical and digital world happen. It gives you control access on the data, provides you control interfaces, and with the AES you have information about your product, but also with the interface allows you to get information from the real assets into the standard. And here is a very simple example on how it looks like. I like actually to bring, it's not completely the right analogy, but if you want to understand how it looks like, you can make an analogy with HTML. So you have like the header, which will provide basic information about digital twin, like identification, name, right? And you have the body, which the asset administration shell word we call is as a submodels. And this is actually the part where the content of digital twin from the semantic part and from the use case part is represented. So we have like submodels for different applications, and I'll give you an overview later on. But here is important just that you have a small understanding and how is the structure and how it's defined. Now, back on the components of the asset shell, and this is also would like to give you as a motivation for you to understand what the IDTA is doing, and for later on to understand what is the role of the Eclipse Foundation when it's about open source. As I said, the AES is a standard for digital twins, yeah, and it can be composed of, so to say, two components, which are being specified in different manners. The one is actually the specification of the standard itself, which is the AS and how it should be then implemented as a software, as an interface, and later on, and also, for example, the meta model. And the second part, as I said later on, with the analogy about the body of HTML or of a website, this is actually the content. So, and of course, the content of the must be also specified in a standardized manner so that every application can understand what's going on. So if it's like a use case, this use case must be commonly understood by different applications and stakeholders. And this is the second part, what's going on. So you have like submodules like digital nameplate and also what Web of Things is doing, like providing the foundation for the asset interface, which provides you the direct access from asset data and bring it to the assemblization shell. So now I gave you the overview and just very shortly present you what IDT is doing. So IDT is providing or driving the specification of the AS. So this is actually rather the bottom part of what you see in the previous slides. So number one you see here. So the specification is composed by the meta model, which is actually providing, like, so to say, the rule book on how to model digital twins. You have the APIs, you have security, you have a data specification, and also the specification on the package file format. And here's what I'd like to emphasize. It's not just the open specification, open standard as IDT is driving, but actually it's also an ISC standard. Yeah, it's the 63278. Why it's important, you'll see later on. But please just take it to yourself. AS is international standard. So this is just an overview of the basics, or the basic specification for AS. But again, this is not enough. So if you want to provide interoperability for different challenges or use cases in the industry, it's also about defining the common semantics, common understanding how a use case should be interpreted by several application stakeholders. And this is actually provided by the specification of submodels. So the submodels will use the, so to say, the rule books provided by the AS specifications to define use case in a standardized manner. Again, like digital nameplates, time series data, software nameplate, you have technical data, 3D CAD, or asset interface. So all of these submodels have actually documented or specified content so that this specific use case can be perform in an interoperable manner. Yeah, and so to say, and I will explain later on, based on the submodels, you will be realizing your use cases, and you'll be also enabling later on what we call digital product plus, which I already heard before, but I will have a slide later on to explain that. So now, understanding that we have like the specifications, we have the submodels, I would just like to bring this slide so that you have an idea what's actually the challenge, one of the challenges that we are solving with interoperable digital twins. And in the end, we are talking about several use cases that are going on in the industry, right? So in the industry, we have the suppliers, we have the manufacturers, and you have, of course, the customers of both, which will be the operators. And in the whole supply chain, there is actually a huge need so that data is transferred from one place to the other in an interoperable manner. So we are all saying that software is eating the world, AI is eating software, but without data, nothing of those will happen. And this is why it's important to provide quality and interoperability as well. And this is what I would like to bring here. Again, this is the, so to say, very generic scenario where you have suppliers, OEMs, manufacturers, and operators. And what I'd like to show you here, that the AS with the several or the different submodels provide or enable the communication with them. So for example, with let's suppose we are manufacturing a car. A car requires have actually several suppliers, like from gearboxes, drivers, tires, etc. So the manufacturer needs data from all the suppliers. And instead of doing like an Excel sheet, which is actually pretty common nowadays, you use the standard AS to get the data and make it interoperable. So you're going to save money, you're going to be more efficient, and of course, with a structured data, like using the AES, you have also better quality on your data. So whenever the supplier shares data with OEM or the manufacturer will be able to consume the data and enable their business processes as well when it shares the data with the operators, right? So you have the like selling a machine to the operator. The operator needs also some information to keep it running or to run it. And here's also like emphasize that AES is not like providing new standard to solve all the problems of the world. Rather, it's going to provide the basis also for you to use other standards like OPC-UA or Web of Things to make your digital twin happen. So there are some protocol standards that are closer to machine. AES is rather, so to say, on the IT level. So it's about the cloud-to-cloud communication, or maybe getting data from devices, enabling the interoperability from applications on the cloud. And so this is where you see some very interesting synergies. Yeah. So it's not only on one way, but also the other way around. So whenever operators want to share data, like servicing to the manufacturer, you use the SM session, and you have the corresponding submodels to enable this interoperability. Yeah, so the bottom line, what you have to take out of this slide is that AES will be helping several stakeholders within the life cycle to talk or to enable their digital twins to speak the same language, like we're doing here. So this is what AES is supporting here. So now, we provide, of course, or the IDTA is specifying the AES. Together with Eclipse Foundation, see later, we'll explain later, we're driving open source. But there's much more than that. Yeah? And this is when we talk about the topic data space. Data space is, I would say, a very important topic, because within the data space, this is where we will make the whole value by sharing data, by processing data from different stakeholders, like from different suppliers, OEMs, operators happen. And the reason why we need data spaces is because we need, what we call trust. We need common rules so that we can share the data in an interoperable manner. And for that, we already several projects going on. You might have heard some talks on this event. But CatenaX, FactoryX are examples for different industry sectors. And here again, the AES as a standard for digital twins will play a very important role, because it will be providing the language for digital twins, so to say. And another topic that I would like to bring to you, and it was already mentioned on the previous talk, again, is the digital product passport. The digital product passport is actually a concept within the ESPR, or the Eco Design for Sustainable Product Regulation from the EU. And this is going to be mandatory actually from 2027 for specific product groups. And one of the things that you see in this EU documentation or regulation is that DPP must be based on standards. And this is where, together with several industry consortia from Germany, we got together and say, look, we already have with AES a great concept where we can actually not only enable the realization of DPPs in terms of interoperability and also from the scope of what DPP should contain, but also provide a basis where companies not only suffice the basic regulation requirements of the EU, but also create value. And so to say, this is where we talk about the digital product passport for Industry 4.0, which is driven by, for example, ZVE and IDTA. Where we say, look, we use the AES as an industry standard. We use a digital nameplate, which is another ISE standard, international standard, to realize the DPP. And based on this concept or this idea of DPPs, I will show later on a showcase based rather on the how to share carbon footprint data, which is actually part of a DPP, so that you understand how AES will be helping there, and then also to understand that actually many things will be supported by open source projects, which is actually driven, of course, together with the Eclipse Foundation. So now I hope you get some idea of the context, what is the AES and what it's being used for and why it's important. Now I would like to give you an overview of the journey, why IDTA or why a big part of the German industry or the European industry believes that if you want to drive new technology, open source is an essential approach to make it happen. But first of all, I'd like to present from the IDTA perspective why open source is important and why we should drive a technology or concept like AES based on open source. Briefly speaking, it's because we want to make it easier for developers to develop applications, to adopt the use the standard, and in the end, also so that the industry have good and high quality, efficient solutions to make their digital twins happen. So it's about using open source as a platform to make AES as de facto standard for digital twin via code. It's about using the very rich community of open source to create a vivid community on that. It's about providing reference implementations where you can provide proprietary solutions on top of open source and provide value to the industry. And last but not least, it's about using this great collaboration model provided by open source to co-innovate, bring openness and transparency. So this is why IDTA, again, is working together with Eclipse Foundation to bring this forward. And here I brought the slide because I want you to make two things very clear. The IDTA is driving the specifications. So the specifications are done within the IDTA. And for that, there are several, or there is actually so to say a clear guideline or a process on how we do this. And there, for example, we have even like a GitHub repository where the specifications will be developed. This is where the submodel templates will be specified. And also we have some use cases, right? So IDTA does this specification. On the other side, we drive open source because we believe not only we need the reference implementations, but also because by implementing the specifications open source, we have a feedback that we can then improve the specifications. Then with the specification, we can improve software, and so on and so on. So in the end, it's about helping both, or using both approaches to make a better contribution for the community. And within the Eclipse Foundation, you'll see soon, we have a top-level project where it's about the software, it's about the code. So this is where we drive the open source code, so to say, development. Yeah. So again, this is very important for me that you understand that actually there are two streams, so to say. There's the specification done by IDTA, but open source is within the Eclipse Foundation. And when we talk about what we do in Eclipse Foundation, I would like to present you the top-level project, and I'll be providing you some examples of our, or some overview of few of our projects, so that you understand what we're doing there and how we are bringing the specifications into open source. So we have a digital twin top-level project, or Eclipse digital twin top-level project. We have a PMC. We are glad that Andreas Ozeski is leading this. Part of the PMC is also my colleague Birgit, Michel Plage, and myself. And I won't spend much on the slides, so you have here QR code, feel free, otherwise just reach out to me. But I would like now to give you an overview on the content of each of the projects, also motivating you if you're interested on implementing software based on AES so that you can use these open source projects. So here's just before I start explaining, we have by now 8 projects, and I think this will be increasing in a few years. And what I'm also happy to say is that we observed that each of these projects are being mature, getting more maturity in terms that it's not only getting better, implementing more the specifications, but also being used as a basis for proprietary solutions. So I will just go through a few slides, giving an overview on what particular projects are doing. So we have like UIs, we have SDKs, we have servers, implementation. I'll just go through them now. The first project I would like to present is the Eclipse AES web client, which is actually rather a UI for the AES. So it implements actually mostly the meta mod of the AES, but also the API, so that you have, of course, some parts of the AES API specification, so that you can actually use technologies like TypeScript or JavaScript to have a representation of AES in your web browser, so it allows you to browsing, editing, updating, and so on. So if you are interested in UI, have a look at this one. We have now projects like provide rather the basis for software development, which are like, so to say, libraries. So we have the Eclipse AS4J or Eclipse model for Java, which is, again, similar to the web client. It's implementing mostly the meta model of the AES and part of the API, so that we have a framework where software developers can build their applications for AES on top of it. And so we are happy actually to say that we are already some time at the Eclipse Foundation. We're already able to provide a final release, so a release following the Eclipse Foundation handbook. So we are also seeing then some adoption of this project. Also within the Eclipse G2 top level community. Another, so to say, basic project is the Eclipse Semantic Modeling Framework. And this is also a project that provides means for other applications to build application or solutions for digital twins for several use cases. And in this particular case, the ESMF describes a new language called Semantic Aspect Meta Model, where you can model the semantic of digital twins. So in this project, we have like tons of things like SDKs supporting several languages, technologies. You have open API specifications, UI components, and of course, editors, so that you can interact and build the aspect models following the language described here. And of course, it's important when you talk about digital twins. It's of course when you also support the standard, and ESMS also has means that it supports. You can use it to support provide information to AES, like semantic descriptions. So you see there's also some releases being planned. So if you're interested in this one, please feel free to connect to the project leads and committers of this project. Now we saw UIs, project for UIs, project providing like SDKs or fundamental libraries for software development. And now there are 2 projects that actually provide a little bit more, which is, so to say, like a middleware for your applications to provide specific use cases. So one is the FAST, actually one of our newest project within the Eclipse Foundation. And by the way, this is still in transition from their previous repositories into the repositories of the Eclipse Foundation. But nevertheless, it realizes the API specifications of AES, so that you have like repositories, registries, servers, so that you can actually have a realized use case related to that. So you can get data from different sources and represent it as AES. Again, this is a new project, and this is still coming from the older repositories to the repositories within the Eclipse Foundation. Another project that has a similar scope, but still different. So while Eclipse Fast is a little bit maybe closer to the device itself or to the edge, the Eclipse Basics may be one of the most mature project that we have. And this is really like a middleware, enabling you to provide realization for several scenarios. So it has 80 SDKs enabling or actually implementing basic components of the AES specification like repository, server, registry, or the discovery. It has also like a UI. Yeah, so it also provides you several of off-the-shelf components that you can even put on top of the AES specification itself. It has also supports different technologies like Java, Python, C#. Yeah, so it's a very pretty mature, and I would say if you want to do some experiments on trying out AES, maybe this is a good place to start. There is also a new project, actually not so new, it's maybe a little bit older than 1 year, but this is actually another example that I like to see that different projects within the top level project are already based on each other. And for example, the Eclipse Service Lifecycle Management, it actually provides a realization based on a research product, actually using, for example, Eclipse Basics for automatic creation of AES-based device self-description, but also software deployment. So you can have a look here and see how you can use, or it provides actually the means to use AES for several uses, or for some use cases described here. So what I also think it's very interesting is that they're already also thinking about the topic Cyber Resilience Act, and they are experimenting on how they can provide firmware updates based on AES so that you are compliant with the CRI. So if you're interested, feel free to reach out to the project and have a look at it. And last but not least, this is maybe the most popular project when it's about AES. It is Eclipse ASX Package Explorer and Server. I think since this year we are actually more active on the Eclipse Foundation in terms of that we brought a code from all the repositories to the repository within the Eclipse Foundation. But this is, in my opinion, the first point to start if you're willing to use the AES. So it's about editing, viewing AES. It provides also a server where you have like the repository implementation, registries, and so on. And so you have actually with this project pretty much almost everything that you need for the trying out the AES. Important here is that it's based on C#, so different than, for example, Eclipse Basic. This is pretty much focused on only one technology currently. Yeah. So these are actually a few projects that I would like that you just have an idea what's going on. And I know this might be maybe too abstract. That's why I brought here an example, which is actually already based on the community that we're building. By the means that we don't only want to create one open source standalone, but we want to ensure that the several open source projects we have really can work together and have synergies. Yeah? And of course, when we talk about standardization, these open source projects have to work with that as well. In this specific case, I'm bringing here the ZVE, which is also the Association for the Electrical Industry, which brought their product camera footprint showcase. And in this case, we have here, as shown, a control cabinet based on several components from different companies. And of course, when you want to share, for example, data from DPP, and this specific context would be the camera footprint data, it must be interoperable. And we use the AES for that. But here, what I would like to emphasize is actually more the technology part of this, meaning that at the first steps of the showcase, we pretty much use only Eclipse or the Eclipse Package Explorer as well as the server. But now we also experimented in a way that you can use also other open source implementation, of course, proprietary solutions based on them, and we really showed that it's working interoperable manner because it's based on this standard. Yeah. So in this specific case, we have the ASX server providing the basis for the carbon footprint application, but several other companies, providing carbon footprint data can use their own implementation, and it doesn't matter if it's open source or not, or if it's proprietary based on open source. Important is that it's using this standard, and this is what we're going to show here. By the way, before I actually brought here a video, before I show the video, feel free to scan the QR code here. This will bring you exactly to the this UI, which is the carbon footprint showcase. Just be aware that it's better if you use a computer to open this application, but just that you have this demo on your hand. So now I will just play the video. It's about 4 minutes, and we'll just go through the showcase itself.
Hello everyone, I'm Stefan, and in this screencast I will show you how DPP 4.0, the Digital Product Passport for Industry 4.0, is used in the ZVAI Showcase PCF at Control Cabinet to automatically calculate the cradle-to-gate product carbon footprint of this control cabinet. For this demonstration, we are taking the role of a system integrator, in this case a control cabinet manufacturer, and we are in the process of assembling this cabinet in our factory. We are using DPP 4.0 to create a digital twin of the cabinet and to calculate the PCF value automatically. At this point, the last product, the circuit breaker, was assembled physically. To include it in our digital assembly, we can use the QR code on the product, the identification link, which identifies the product and leads to the DPP 4.0. By scanning the ID link with an app, for example on a handheld device, the DPP 4.0 is retrieved, the product is added to the digital twin, and the PCF value of the control cabinet is automatically updated using the documented PCF value of this product. Let's take a look at the digital twin. What you can see in this dashboard is the digital representation of the control cabinet that is currently being assembled. On the left side, you find an overview of the products that are already installed in the cabinet, as well as the current PCF value for this state of assembly. Each product features the DPP 4.0 based on the asset administration shell, which can be displayed by clicking on the blue buttons. The PCF submodel contains the relevant information that is used to calculate the product carbon footprint of the cabinet. As mentioned before, we are able to add the circuit breaker as our last product digitally by scanning the ID link with our respective app. Now, the circuit breaker is in our list of products, and the PCF value represents the total value for the control cabinet. The dashboard demonstrates two more features of DPP 4.0. The first feature is the storage of DPP 4.0 information in a distributed manner. DPP 4.0 is not stored on a central database, but rather hosted by each manufacturer on their own infrastructure. This can be seen in the dashboard when inspecting the DPP 4.0 of different products. The information for the recently added circuit breaker, for example, is hosted by ABB, whereas the information for this interface module is hosted by Siemens. The second feature is the control of access rights for the DPP 4.0. At the moment, we are authenticated as Albert, who has access rights to all information in the DPP 4.0 of all products. However, Steven is Sustainability Manager and should only be able to access information that is relevant to verify the PCF calculation. Therefore, when we authenticate as Steven, the DPP 4.0 of all products is requested, and some information of the DPP 4.0 of the product becomes unavailable, as visualized with the red text as well as the padlocks. This demonstrates that not everyone who has access to the ID link on a product can directly access all information about the product. That brings us to the end of our screencast. Thank you for joining me, and do not hesitate to contact me if there are any open questions.
So again, just to summarize what you see here again, this showcase was willing to show how important standards to enable the sharing data of such important topics like DPP or, for example, camera footprint. And again, the whole showcase actually is built on open source. Actually, it's specifically the ones that we have now in the Eclipse Foundation, and it shows clearly if you want to bring new technologies into the market, open source will be helping this. Yeah. And this is what we are achieving here already with this demonstrator. So to finalize, again, just to summarize with what I brought here, again, I hope it could give you an overview. What is the AS? If you're new, I hope you understand what is it and what's for, and you are motivated to learn more. If you are not new, I hope you learn either more or you just understood a bit more what it's for. But last not least, AS will be important to solve several issues or several challenges like data spaces, like DPPs. And last but not least, open source is playing a very important role here. And by the way, this is providing the basic components for solutions enable as administration shell and digital twins. By that, thank you very much for your attention, and feel free to reach out to us if you have any questions. Thank you.
Yes, thank you for the presentation. Just one question, you mentioned it a little bit. You showed us the differences between Eclipse Fast and Eclipse Basics. So could you give some recommendation when should we use Fast and when should we use Basics?
So the first question would be, what is the use case you are trying to realize? Because this is actually the answer you're looking for. So both provide you somehow a middleware or very powerful SDKs to make your solution based on AES. So fast is, so to say, closer to the edge. So closer if you have like a real device pumping data. So fast may be the right choice for you. But if it's about cloud-to-cloud communication or scalability, then you might rather look for Eclipse Basics. And finally, maybe it's even a combination of both because each of the project has a certain focus. So my recommendation is first to analyze what is the use case you're trying to realize, and based on that, realize either you go for Basics or for Fast. Otherwise, feel free to reach out to the committers because anyways, it's the best way how to start using the project. And of course, if you're feeling free, feel free to contribute to the project as well.
You mentioned other projects coming into the top level projects. Could you detail what is in the horizon?
So I cannot officially tell because it's not depending on us or on me, but there are still some other projects that are on the old, so to say, IDTA repository, and we are moving either all of them to the Eclipse Foundation, or even if those that are not relevant anymore, we're going kind of say to close them, because they're not going to be used anymore. But this is what we expect. So either the old ones or they're actually even sometimes surprised me. There are a lot of projects going on AES, and sometimes there are some open source implementations, and they go often to the Eclipse Digital Twin top level project as a home for their projects. But if you have some, feel free to reach out to us and you'll find a new home here.
Thanks.
I have another one.
Yeah.
Linking to the what you were saying as takeaway for
sorry,
data.
Sorry, can you I could
yes.
not hear. Yeah.
Can you hear me? Okay. Linking to your first takeaway when you are mentioning that this is enabling data spaces, just to test my understanding, there is no data space technology on AAS. What you are saying is that, as usual, for data spaces, we need data, and therefore it is a way to combine this with data space open source technology, and therefore this is what is being done in Manufacturing X or Catena X. So it is a combination of this technology, which is purely for digital twins, plus the data space technology, right?
Exactly. Yeah. So I mean, it was maybe not very clear, but yeah, data space is not only digital twins, but much more. You know, you have like the data space connectors, which is also have a home at the Eclipse Foundation. Have other other things, but the AAS or the SMC shell is just providing the means to represent digital twins in an interoperable manner. All the rest, of course, I mean, AS. It's not providing them, but it's using the framework that will be defined for these data spaces. Like it's already done in the Catena X and is an ongoing on Factory X as well.
Thank you.
All right, then. Thank you. Otherwise, feel free to reach out to me or to the community. We're happy to help. Thank you.